Okay, this is stuff coming out at 9. So I'm almost there, almost home and dry. No, not dry today. I'm going to erase the block diagram. Okay, I'm going to erase this because I want to complete the problem. Is everybody fine? Yes, question.
Could you put a gain on each of the input signals, a gain of 3? Would that be equivalent to having a gain on the output of your app?
Absolutely, absolutely. I could, so instead of having 3 there, I could just multiply this by 3. I could have a 3 by s plus 1, which is kind of hard to do. That's why they wanted to put the 3 there. If you do it in MATLAB, 3 by s plus 1 is difficult. Okay, that's the reason. But if this were just a constant, right, you could just put that there. That's fine. So as I said, no one single way of drawing a block diagram. Many different ways. Many different ways. I'm going to erase this. We're done with this figure. Okay. Work with this. Take the x of s as common factors, multiply, and bring them onto the other side. So I have x of s 3 times x of s, s squared, s plus 1, plus 3 times x of s, s squared, s plus 1. What am I doing? I'm taking a 3 by s squared, spreading it inside the brackets, and then taking all the x of s terms common. Bring them onto the left hand side. What do I have? 12 by s, x of s is 3 by s squared, f of s. Common denominator everywhere. S squared multiplied by s plus 1. X of s is a common factor. If I do that, I have s squared, s plus 1, 3, 12 times s plus 1. This is 3 by s squared, f of s. All I did was take common denominators. Okay. Then start multiplying everything and adding things up. I'm going to have s squared. Then I have a 12s, I'm sorry, s cube. This is s cube. S squared. 12s. And 12 plus 3 is usually 15, so I have 15 as well. X of s. Cancel the s square on the denominators. And so this is 3 times that guy. This is a third order ODE which you will never see in this course. There are very few systems that actually exhibit third order dynamics. You can see fourth order dynamics in beam bending equations and so on. Third order dynamics are seen mostly in systems that are plasma type systems, electrical discharge systems and so on. So we don't do things like that here. Okay? At least not this semester. Take the inverse Laplace. If I have an s cube times x of s, inverse Laplace is x triple dot. Okay? So invert. S cube times x of s is x triple dot. What is s square times x of s? Becomes x double dot. 12s is 12x dot. 15 times x of s is just 15 times x of t, because you're now going to the time domain. Factor of 3, you can either leave it or spread it inside. So 3 times f of s is 3f dot, and then 3f of t. And this is the system mod. Okay, write this down. Thank you. I'm happy to answer questions here.